Don't forget that this is a detailed reasoning question, so you are asked to show detailed reasoning. Questions that have this at the beginning require an extra level of flow and logic. Make sure that you present your solution as a perfect logical reasoning. It should read like it should read like a paragraph of sentences. Otherwise, actually, relatively straightforward question apart from the very last bit. Gradient of this curve, so differentiate. We want the gradient to be positive, so gradient expression greater than 0. I'm going to factorise that now. Let's just come back a moment. If you're wondering how to factorise this, grab your ClassWiz calculator and just go onto the solve function and just solve it the normal way, because you can reverse engineer the factorised version of it. What they're trying to get you to do is to not use your calculator, but you can still use it and then sort of fill in the gaps to make it look like you haven't used it. So get on your ClassWiz and type that in and solve it and get the answer, which will come out as eventually that. Your ClassWiz will jump straight from here, ignore everything else, and it will give you this. You can use these values, x minus 3, to write down x plus 3 as a factor, and x equals a half gives you this factor here. You're not going to write x minus a half because you know it needs to be 2x, so you write 2x minus 1. So you can quickly factorise by sort of solving the quadratic. Now I want to go back to where we were and go through this process of solving, because I think jumping straight from there to the answer, again, if you're showing detailed reasoning, it might not be enough. So how do we solve inequalities like this without a calculator? Well, you sketch the graph of y equals 2x minus 1, x plus 3, which is a quadratic. You mark on the roots, minus 3.5, and then we think curve is above the axis, above. So which values of x causes you, if you're an ant walking along this line, you're standing here, you have to look up to see the curve. If you're standing here, you have to look up. If you're standing here, you have to look down. And we want to have to look up. So we want to be left of minus 3 and greater than a half, which gives us that result that we've already seen. Now, to get the last mark, you need to do something that actually makes me quite frustrated, because surely this nice, simple pair of expressions here, or inequalities, should be sufficient. You know, it's quite simple, it's easy to understand, everyone gets what that means, so why would you write that in a more complicated way? And the answer is, well, mathematicians simply wouldn't write that in a more complicated way. This question is just testing that you understand how to use set notation to describe a range like that. So here's how to think about it. You can't do this. I'm just going to ignore the half one at the moment. Just concentrate on this one. You can't write the set of x is less than minus 3. It doesn't make sense. You can't put x is less than minus 3. You can't put that statement into a set, into a box. You have to put x values into a box. So we're trying to have the set of objects that are less than minus 3. In other words, you're trying to have a set of objects such that those objects are less than minus 3. So think of that as it's a set of objects, and then the objects are described, these particular objects are described in this way. So there's sort of two bits to it. Set of what, and then what are those things? Describe those things. Instead of writing such that the objects are less than minus 3, you could use a colon and say it's the set of objects where each of those objects is less than minus 3. But instead of using the word objects, let's just use the letter x. So our final answer is to say it's the set of x where those x's are less than minus 3. That's the correct notation to use. If we do the same for the other part of the range, and then sets, remember you want both of those, you want this set, and is, well, it's a union, technically it's not but you want the union of both of those, and that's our final answer for that last mark.